My name is Ashu Thakur, and I am from NEC Corporation. NEC Corporation is a Japanese multinational company. So I'm a business consultant. Unfortunately, there are other two members from core development team from NEC Japan team, right? Mr. Sourav Saha and Kazuhisa Ishizaka, who has actually, worked on this FireDucks, which is, as our title says, that FireDucks Pandas Accelerator using MLIR. Right. So I will be briefing you about what exactly we are trying to do over here. Is that let's try to understand the workflow of data scientists. What exactly the data scientists always try to do, and where they try to spend their time most of the time. Right. So generally they get the raw data which is having a misinformation or something which is not I would say that. Information which is not required, right? So in that case, they load the data and then they clean it, and then they try to visualize the data, right? So that's how the process follows. And then they work on the model, which is one-time task over here. So after that, what happened is that we input the data and then process the data. But then we think about it like where we can optimize the processing the data is actually where the optimization is required. And as we see from the Anaconda side, left-hand side, you can see that most of the 60 to 70% of the time and cost spent on this, data loading, cleaning, and visualizing. So that's how. So it's important to data preparation optimization is required over here. So when we talk about the data preparation, Panda is the most important tool over here, which is the most popular Python library for data analytics. When we talk about Pandas, it's having approximately, I would say, more than 150 plus downloads every month, right? Since Panda is so popular, and it is, I believe last 15 years, a lot of data scientist communities are working on this Pandas. But yes, it brings a lot of drawbacks. Few of them I would like to highlight over here are like it does not support the parallel computation, because if someone who is working on the a system who has a multi-core and I mean, Pandas does not support the parallel computation, so it generally work on the single core. So that is one of the drawback, I would say. And apart from this, it has a lot of choices for APIs. So it's for the same kind of task, right? So to choose a right API, which heavily impacts the performance of the Pandas application. So this is also, I mean, if you're not doing it, so then performance may impact, right? And the third one, which I would like to highlight over here, is that a very slow execution nature of the Pandas. So if you have a very large data and a lot of queries to execute, then probably you might take a lot of time to do so. So that is why the third one is that the slow execution of these Pandas. And the fourth one, due to this, obviously, a lot of guys are working on the cloud these days. So if it is a slow, long-running execution, then obviously the product produces higher cloud cost for this, and which can attribute to adding a lot of servers, can attribute to a higher CO2 emission. So yes, we are also thinking on the optimization perspective, plus environment friendly and the cost friendly also. So. Next slide, I would like to talk about how we can optimize, queries in a better way. Let's discuss about the sample query first, and then we will, try to optimize the same query further. So as you can see that we have a data frame, right? And what we are trying to do over here is that, I mean, just for people who don't know, we do the sort for sorting and query for filtering, and then we do the projection for selection, and then we slice it up the top results we needed for that. Now, what we are trying to do over here is that we are, having a data frame which has the columns like A, B, C, D, E, right? And we need a sorting order for that: yellow, red, green, and blue. So we are sorting the A column here, right? And we are getting this this sorting order, this which is yellow, red, green, and blue. Now, let's assume that, I mean, for better understanding, let's do one thing, that rather than going for numbers, let's try to focus on the color code. So let's assume that one is the darker shade and two is the lighter one. So we are filtering over here, putting a query that B is greater than 1. So we are getting the, by filtering, we are getting the lighter shades over here. Now what we are doing over here is that we are projecting E column. By selection of E column, and then we are slicing up the top 2 results which we needed from here. So this is the sample query which I wanted to highlight to you. And then now we need to understand that we have done our operation in the entire data frame table, right? Now we need to understand that there are only 3 columns which where our operations are working, like A, B, and E, right? C and D columns are not required here. So just to optimize further, what we are going to do is that we will select this time A, B, E to conduct our operations. We will be doing our projection on A, B, E only rather than C and D. So in here we are reducing the data scope from the column side, and then further to it we are filtering again on the row side. So that means we are filtering the lighter version, lighter shades, right? So we have reduced on the column side the data scope and reduced on the row side. Now we are sorting again on the, as we have asked, like yellow, red, green, and blue, right? And once we have sorted, we are doing the projection on E column, and then we are getting a slice 2. So what we are trying to do over here is that we are doing our operations on the limited data scope or reduced data scope, so that the optimized code we can get it from here. So this is the just idea I wanted to give it to you, how we can optimize the query in a better way. Let's take the, this is the TPCH benchmark, right? And we have taken a query 3 from here. So you can see that there are 8 columns, customers data related 8 columns we have, right? And we are trying to retrieve 10 unshipped orders with the highest value. We have the SQL implementation at the top, right? And we'll try to write in a Pandas way. So here you can see from the SQL side that we need to do our operations. We need the information from the 3 columns only, which is customer, orders, and line item, right? The customer, line item, and the orders. So what we will do is that we need to join this. We will need to joining for this. Like we will take the customer key from the customer table, an order key, a mask with the order key for the order table. And similarly, similar kind of operation we'll do for the order key from the line item and order key from the order table, right? So once we have done it, right, we are similarly doing it customer.merge for the customer key from the customer table and order key from the order table. These two tables are merged, we'll get a one table. And similarly, dot merge for the line item table and order table. So we have done the similar kind of joining and operation here in the Pandas also, as we have done the SQL version implementation. Now what we are trying to do over here is that in SQL we are filtering the market segment which is building, in this customer table. And then we are saying that order date should be less than this date. Order date should be less than this date, right? And then shipping date from the line item table should be less than this date. These are the columns which we are filtering out there from these 3 tables. Similarly, we are piping and filtering over here from these table in the Pandas way also. And then what we are trying to do over here is that we are creating a new revenue column by multiplying the extended price with the discounted price to create a new revenue table so that we can get the highest value. Similarly, we can apply this method by applying this assign method in the Pandas to do so. And then we will do our group by activity, group by operation for order key, order date, and shipping priority. And then we will do our, similarly as we are doing in SQL, we are doing in Pandas. And then we will do our aggregate for the sum of revenue columns so that we can get it highest values, so what we are looking for. And then we'll do the sorting and then we'll slice it up to the top 10. What I'm into to say with I'm just trying to show that how we can write the SQL implementation to the Pandas way. And as you see that there are lot of columns and then we have a lot of rows under it. So it is a huge data to process. Now further, we will try to optimize this Pandas code further to it. Now what we are trying to do here is that, as we have discussed in previous slides, that we are trying to reduce the data scope. Similarly, that's the way we will try to reduce the data scope over here also. What we have discussed earlier, that we need a customer key from the customer table. So we are doing a projection for the customer key from the customer table and the market segment from the customer table. Similarly, we are projecting this market segment from the customer table. Now, what we need is that we need to filter this market segment which is building. So this is how we have reduced the column level, customer key and market segment, and then we have reduced on the row level, right? Similar kind of operation we are doing in the order table, where we are saying that, okay, we need customer key, order date, and shipping priority to do a projection, right? And as you can see, there are 9 columns from the previous slides, and we were just focusing on 4 columns out here in the order table. A similar kind of operation we are doing on a line item, where we are focusing on the order key, ship date, extended price, and discounted price, where we have 16 columns and we are focusing on the 4 columns. And then further to it, we are filtering by saying that shipping date less than should be greater than this date. I'm sorry for that. Yeah, so it means that we are reducing the column and we are reducing the row. So and then we can further to do our further operations like merge on the limited data scope which we have decided right now, right? And then further assigning method, filtering, group by, and sorting, and then slicing up the top 10. It means that once we have reduced the data scope, we have optimized Pandas. Now, earlier it was taking 68.55 seconds. Now it will take 10.33 seconds, which means that we are reducing 6.5 times lesser than what we were getting earlier on. Now the question comes is that, can we automate it? Yes, of course, we can automate it. And we can automate it by, with the help of compiler-driven technology, right? Now, as you can see that we have a, optimized query over here. So what we are trying to do is that with the help of LLM VM, we are, breaking into the intermediate representation, right? So you can see that, the Pandas API is representing its intermediate representation, which is like, let's try to understand this one, that it says that its sorting values V1 based on a column. I mean, just to tell you, we are taking this query only, right? And based on that, we are getting V2 result, and further to it, we are doing a filter on V2 based on P is greater than 1, and then we're getting the V3 result. Similarly, projection is done on the V3 based on E column, and then V4 we are getting a slicing of the V4 and getting the top 2, and the result is the V5. So what we are trying to do is that we are getting the query into and breaking into the intermediate representation instruction. Once we have done that, we will create some kind of engine which will give us a reorder or optimized version of this IR representation, right? So what we see over here is that what we have discussed previous slide also, that we will project automatically. It will give us A, B, E column. We will do the projection on A, B, E column, and once we have done that, we will do the filtration, then sorting, projection on E column, and then slicing up top 2, right? So this is the way we can get an optimized IR. Sorry. And then what we can do is that we can, translate it back to the Pandas API. But really, do we really wanted to do that? Because if we have done so much of work, why do we want to, translate back to the Pandas API? So we have a, better answer to it, that we can create some kind of backend library which can be on Python or C++, right? And then we can generate, I mean, this process we have discussed already, right? We can generate an IR instructions, and based on that, we can, reorder this in these instructions, and then we'll send it back to the a backend API library, right? And then this way we can, have a front end with Pandas API with Generate AI, develop our own library parallelizing with the workload of data frame related method as a backend. So it means.
Yeah. May I request you to wind up? We are eating into time of question answers.
So just
please wind up quickly.
2 minutes,
yeah,
2-3 minutes. So just we are parallelizing or multi-threading all the operations, sorting, filtering, and projection over here. So we have come up with the FireDucks over here, which is automatically doing everything for you. It has a lazy executions, right? And it fully exploit the multiprocessor rather than Pandas on a single core, right? And the FireDucks is compatible with the Pandas API. And it is also seamless integration is possible without, not only on existing Pandas program, but also the external libraries like Cbon that internally use the Pandas data frames. No extra learning is required, no code changes is needed in this FireDucks. So we have already discussed what we are doing or try to do over here, right? And just a usage of FireDucks, I would like to tell you that you just once install the FireDucks, then you just need to do import of fireducks.pandas and your program will be accelerated. And for the import hook, if you don't want to do any modification, right, which is in program is based on Pandas, and also you have the internal modules like A and B which are on Pandas, and you can't change that, import Pandas with import fireducks.pandas all the modules. So you can do that. You can put -m fireducks.pandas, and it will automatically accelerate without changing the zero code modification. And also if you are working on the Jupyter or Colab, you can just put this instruction and simply integrate this on the notebook. And these are the few benchmarks for group by and join algorithms. You can see the FireDucks is performing very well on the top of it, and Panda is the third last, I would say, and fourth last in this. And these are the benchmarks on the TPC benchmark. We had discussed on the query 3 only, but there are 22 queries where you can see that the FireDucks is a lot better than Polars and Modern in this benchmark. These are the TPCX BB benchmark, and which generally data scientists follow the process, where you can see that the FireDucks speed up from the Pandas also. Okay, so this is the important thing, the source on FireDucks, that we have a website, right? You can come and take the user guide, benchmark, and blogs. We are also releasing our version informations on the X. We have the GitHub link also, where you can issue reports, and the most important is the Slack channel, where you can come and ask questions and communicate with our code development team, and join with us. And this is the collab link where you can do a test drive. And thank you. Focus more on the depth data exploration with using Pandas. Let's FireDucks take care of the optimization for you. Enjoy green computing. So guys, just want to tell you, this is only on Linux right now. Mac and Windows are going to release in another probably 2 to 3 months. And also it's the tests are on CPU only. So GPU version will be releasing, I think, or maybe on January or February, might be very soon. So that's all from my side. Thank you. Thanks.